Hey everybody, this is Larry, this is me going with Q2 of the bi-weekly contest 97. Maximum number of integers to choose from a range 1? Huh. Are they already thinking about a sequel? That's kind of a spoiler alert, isn't it? I actually did not read the problem, uh, or the name of the problem before reading this problem. But anyway, yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and how I did during the contest. So, yeah, I think the key part here is just honestly just look at the constraints really quickly, and that really depends. But to be honest, I don't even know if the constraints actually matter that well. I mean, if n is really big, then we have to figure out some maths on one of those things, right? Because depending on constraints, maybe maybe you have other techniques that optimize for certain constraints. But I'll get back to this in a minute. So the thing is that max sum, it doesn't really matter because it's just the sum of numbers. But because this could be infinity for all you care, as long as the other two are reasonable. The band integers you can put either in an array or in a set, depending on the length, and n is also 10 to the fourth. When I saw n is equal to 10 to the fourth, I knew that 10 to the fourth is 10,000, which means that you can loop through it. And if you can loop through it, then you can check every number. And here you want to return the maximum number of integers that sum to some number or less than sum of some number, right? So immediately that says to me greedy. And what I mean by greedy here is that we're taking the smallest number that we can choose every time and keep on looping it until it has max sum. And that's basically what I did here. If we have it on the band list, we continue making sure that we put it in a set. Otherwise, this is going to be linear. And I made this mistake before just on a typo, so it's it's very sad when that happens. But yeah, but otherwise, if you add this number and it's go over the max sum, then we can return. Otherwise, we add the number, we add the count, and then return the count at the end. So yeah, so depending on the constraints, there are other ways to kind of solve this. For example, if n is very big but band is only like still 10 to the fourth, then you may do some maths on some binary search maybe is an easy way of doing it, but you could probably do it more analytically with respect to just kind of like the sum of the first n numbers is like n times n minus 1 over 2 or something like this. Well, I always mix that up, but and then you kind of finagle the band list from it, for example. So that's another way of doing it, and you could do it in this way today too, but that's just way more complicated, I think, or at least maybe not more complicated, just easier to mess up in either case. Cool. This is going to be, I want to say O of n time, but in this case n is not the size of the input. N is the input, but it is not the size of the input, so you shouldn't say that this is linear time per se, unless you do it on the size of the band list, but maybe that's like another input variable anyway. The way that we did it, given that this n is represented by log n bits, this is actually an exponential function. So the complexity is actually n is the size of the input, then this is actually O of 2 to the n plus b, say, for the size of the band list. So yeah, and yeah, maybe you could say also O of b band space, right? Maybe you could also add some other stuff, assuming whatever. But yeah, that's all I have for this one. So let me know what you think, and you can watch me solve it live during the contest now. Let's see, pending. I don't know why I'm wasting time thinking about it. Okay, let's see. This is gonna be a weird contest video. N and max sum. You're choosing some number of integers. 1 and n. Each integer can be chosen at most once. 1 to n. Sum of the chosen max sum. Maximum number of integers you can do. Okay, so just greedy, I think. 207. Okay, good. 207. Make a bunch for. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, and how you're dealing with it. Yeah, that's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.